Okay, Calcsters. Today we're going to do little differential equations before lunch, little slope fields after lunch. Slope fields? It can be incredibly easy if you look at it at the most basic level, but then there are some where they start throwing natural logs in at you, and then it gets a little hard. Okay, but that's after lunch. So before lunch, we're just going to work with differential equations. So you need to know the difference between direct relations and inverse relations. Okay? So if two things are related directly, as one increases, as x increases, y will also increase. And k is their constant of variation or constant of proportion. Okay? An inverse relationship, as one increases, the other decreases. So we normally write it as y equals k over x. Okay? So the gas laws, volume, pressure, temperature. Okay? From chemistry, some of those are direct variations, some of those are inverse variations. PV over T, P1 V1 T1 equals P2 V2 T2, right? So if you look at pressure and temperature, they're directly related. As the pressure increases, the temperature increases. Okay? So if you want to get the constant alone, that's how we get P over T. If we look at pressure and volume, pressure and volume are inversely related. So as the pressure increases, the volume is either staying the same or decreasing, but if the pressure increases and your constant stays the same, your volume has to decrease. Okay? So that's the relationships. So how does that relate to what we're doing? Well, when you're working with differential equations, you're looking at how things are increasing and decreasing. Okay? The warming or cooling rate of a drink is proportional to the difference between the ambient temperature, T sub A, and the current drink temperature, T, of the drink. Okay? So, if we're doing this with differential equations, it's not the temperature at that time, it's the change of the temperature. The change of the temperature is dT over dt, change of temperature over time. Okay? So if it's directly proportional, it didn't say inverse, this would be an inverse relationship. This would be a direct relationship. Okay? So if it's proportional, it's a direct relationship, and it's the ambient temperature minus the temperature. Okay? This is what's happening right now. This is the change in. So we want to use the change in. Okay? As a particle moves along a straight line, its speed is inversely proportional to the square of the distance. Okay? Inversely proportional to the square of the distance. So this is what's happening now. This is its change. So we want the change one. And since it's inversely proportional, we want this relationship, k over the square of the distance, s squared. Okay? Let's do one more. A chemical diluted out of a tank by pumping pure water into the tank and pumping the existing solution out of it, so the volume at any time t is t equals 20 plus 2t. Or the volume equals 20 plus 2t. So the amount of chemical in the tank decreases at a rate proportional to z and inversely proportional to the volume of the tank. Okay, so the volume of solution in the tank is this. So that's inversely proportional, so this should be on the bottom. Okay, it's proportional to z, so z should be on the top of the fraction. So this is our numerator, this is our denominator. Okay, and then denominator, numerator, and then it's dz over z, And so it would be choice D. Okay. All right. Habitat of prairie dogs can support at most M dogs. Okay. The habitat's population grows proportionally as a product of the current population and the difference between the most and the population. So the difference between the population and as a product of the population and the difference between these two. So the product means we're going to multiply by the difference. Okay, so we have to multiply by the difference. And it's proportional to that. It doesn't say anything about being inverse. So there's nothing to do with inverse. And so if it grows by that, what's the difference between these two? Oh, that's K sub M. So it has to be this one, KP. Okay? So that's the basics of that. All right. Then we're going to be finding solutions to differential equations. So is this a solution to the above equation? To figure out if it's a solution, we have to take the first derivative of this. Well, what's the first derivative of that? Well, y equals negative 1/4 x plus 3/4. So what's dy dx going to be for this function? Negative 1/4. Okay? So we plug negative 1/4 in for dy dx. Equals x plus, what is y equal to? Well, y is equal to this. So we plug that in for y at the top equation. Negative x over 4 plus 3/4 minus 2. And then we're going to solve this to see if both sides are equal. Okay, so negative 1/4 equals x plus, and then negative 4 over 4 is negative x. 4 times 3/4 is plus 3. And then we go minus 2. So the x's cancel. 3 minus 2 is 1. Is negative 1/4 equal to 1? No. So then this one is a no. That's not a solution. Let's do that again. Is this a solution for this? Well, to see if it's a solution, you have to find the first derivative of this. What's the first derivative of this? Chain rule. Yep, so you take 2 times 3 times the ln of x squared times the first derivative of the inside, which is 1 over x. So it's going to be equal to 6 ln of x over x. That's what the first derivative is. So you set 6 ln of x over x equal to, oh, yes. Thank you. 3 times the function, which is 2 ln of x cubed over x ln of x. Okay, so 3 times 2 is 6. So you have 6 ln of x cubed over ln of x, which then cancels down to be ln of x squared over x. So yes, they would be the same. That look on your face is not very good.
I don't know how did we get the 6 ln of x squared to 2 ln of x cubed?
Okay, so you're plugging it into this. 3 f of x over x ln of x. Okay, you're plugging it into that function. All right. So this one. Whoa. Going back up.
So, oh, f of x and then ln of x. You know. Okay.
So you take the first derivative of this, which is this, and then you stick that first derivative on this side of the equation, and then you plug this into that side of the equation, and you solve to see if they're equal. Okay. All right. So this one, take the first derivative of this. So what's y prime going to be? Well, it's 2 times 9 plus x squared to the negative first, right? That's what y is.
Yeah.
So y prime equals negative 2 times 9 plus x squared to the negative second times the first derivative of the inside, which is 2x. So y prime equals negative 4x over 9 plus x squared squared. So you set that, you replace the y prime with the negative 4x over 9 plus x squared squared equal to x times y squared, this thing. You stick it in for y squared. So it's 2 over 9 plus x squared. So the only issue is that when we do this, we have negative 4x over 9 plus x squared squared. Here we have 4x over 9 plus x squared squared. So it's the difference of the sign. So it's a no. Okay?
Okay.
So that's what we're doing today before lunch is first we're figuring out the proportions in which equation is the correct equation.